start, that is Paget's rule and its applications for, that is Paget's rule and its application for polarizing power and polarizability. Now these are the next point as per the ionic solids. When we have taken Paget's rule, that is, this will be the name of the scientist, that is the Paget. In 1924, Casimir Paget have been discussed, have been derived. That is one rule for the ionic solids. When we have taken as ionic solids, they can be formed as a covalent characters. This idea is first of all given by the scientist Paget, and hence it is called as the Paget's rule. And this will be associated with the application for polarizing power. Now polarizing power is associated with the cations. That is, when we have taken as a cations, polarizing power can be associated with the cations, and polarizability, this can be associated with the anions. Now when we have taken anions, this can be possesses polarizability. Again cations, polarizing power. This idea can be explained in case of the Paget's rule. Now what happens in case of the Paget's rule? Now when we have taken as the ionic compounds, they can be generally formed by taking of the different types of the positive and negative ions. Again, they will be also possesses high MP and high BP due to strong electrostatic force of attraction. But generally what happens here, in case of the Paget's, in case of ionic solid, there is a presence of covalent bonds, and due to formation of the covalent bonds, these ionic solids, they possesses low melting point, low boiling points, and some ionic solids, they can be formed as a colored by using of the colorless ions. Now this reason can be explained by the scientist Paget in the degree of polarization effect. In the degree of polarization effect, that is the scientists have given, that is why the formation of covalent bond can be takes place in the ionic bonds. Now this idea can be given by the scientist Paget, and hence it is called as the Paget's rule. It can be explained in the form of the polarizability, how this polarization can be takes place in the cations and anions. That is, three steps can be explained for the polarization of cations and anions. Now first of all, that is, when we have taken as the cations, it can be possesses small size. That is, if we have taken this will be the cation, it can be possesses small size. Again what happens here, if we have taken as the anions, this will be possesses large size. In case of first figure, no polarization takes place. You can say here that there is no polarization in the first step. Now again second step, what happens here, this is the cation, it can be possesses small size, it can be attaches to the, you can say this will be the anions. How the anions can be attaches, you can say here, that is, now secondly here, that is the negative part of the this anion, negatively charged of the electrons of the anions, it can be attracted towards the positively charged cations, and nucleus which is positive as concerned to anion, it remains here, that is repelled conditions. You can say this will be the cation and this will be the anion. Both can be attracted together. Positive charge, this can be taken attraction by the negative charge of the electrons, and therefore nucleus remains in the repelled condition. This can be shown here. Here it is called as the second B anion polarization. That is, second will be anion polarization can be takes place. Now third condition, what happens here? Here third we have taken this will be the cation. Now it can be attracted by the anions. You can say this will be the negative charge particles. This will be taken as here formation of covalent bond can be takes place. In the third step, there is a covalent bonds, and totally the resulting of the covalent bonds, this can be reduces due to this covalent bonds, low melting point, low boiling point. In case of the ionic compound will becomes. This will be explained with the help of the polarization effect. Now polarization effect means what is the polarization? That is the here cation possesses, that is the cation which can be possesses, the cation having the power to polarize the anions. This power it is called as the polarizing power as concerned to cations. Again when you have taken that is the anions, anion possesses, it can be undergoes the polarization by the cations, and hence it is called as the polarizability of the anion can be taken. And once the cation can be polarized to the anions, this process is called as the polarization. And when polarization can be takes place, that time neutralization process can be occurs, and this can be occurs that time covalent bond can be forms. And generally this covalent bond can be explained in the three manners. Three factors can be explained as per the, you can say, the rule, Hagel's rule. Hagel's rule can be summarized within 3 points. First point can be taken as, that is the covalent characters. Covalent characters increases due to decrease in the size of cation. Size of cation, or it can be increases, or you can say that is increase of the charge. Increase of the charge will be also taken in case of the cations. When we have taken as the cation possesses 2 points. First would be when the size can be decreases, covalent characters in case of cations can be increases. Again, if the charge can be increases, covalent characters can be increases. Now this will be explained in the first point, that is if we have taken here that is CaCl2, again BeCl2, both will be the same group, second A group containing calcium, barium, these are the cations, B2 plus, A2 plus. Now here what happens, calcium is top and below to the barium, therefore the size of beryllium is very small as compared to calcium, and therefore the covalent characters can be developed in case of BeCl2 higher as compared to CaCl2. Means BeCl2 always possesses that is large covalent characters as compared to CaCl2 because of the size of B is very small. Now again when we have taken as the charge, as concerned to charge, this can be explained as NaCl. Again you should take CaCl2. Again you should take AlCl3. Now these are the three cations, Na plus. Again when we have taken Ca2 plus, again this will be Al3 plus. Now here charge can be increased 2 plus, 3 plus. That time what happens here? The covalent characters in case of aluminum can be increases as compared to sodium because charge of the cation can be increases. Now this idea can be explained in case of the Hagel's rule. First rule, it can be used that covalent characters increases due to increase of the size of the cations or increase of the charge of the cations. This is the first point. Now again second point can be taken as covalent characters, they can be increases with the anions as concerned to increase in the charge, increase in the size. When we have taken as the size increases, when we have taken as the anions, now here the statement is made as covalent characters increases in the anions due to increase in the size, increase in the charge of anions. When we have taken here, that is the phosphorus P3 minus. When we have taken arsenic 3 minus. Now such types of charges when we have taken again I minus. Now generally what happens here, in here that is the charge can be increases. That time what happens, automatic what happens, the covalent characters can be increases. This idea can be taken in the second points. Again third point can be gives the information that when we have taken as the non-polar characters, or you can say covalent characters. This covalent character is also called as non-polar characters. Non-polar characters or covalent characters, they will be increases, they will be higher in case of non-noble gas configurations as compared to the noble gas configurations. Now when we have taken as the noble gas configurations, that is non-noble gas configurations. Non-noble gas configuration when we have taken, that time generally what happens here, 18 electrons will becomes S2 electrons, P6 electrons, D10 electrons, they will be taken as 18 electrons. And noble gas configurations when we have taken noble means here 8 electrons can be taken, S2 P6. Now what happens here, covalent characters are higher, they will be larger as compared to 18 electrons containing non-noble gas configurations. These are the elements. Then the noble gas configurations where the 8 electrons are present, S2 electrons, P6 electrons. Why this can be happens? This can be happens due to presence of here d orbital contains electrons, here no d orbital comes. Shielding of the electron, that is the shielding effect, this will be generally higher in case of the d electrons, and therefore generally what happens here, shielding effect when comes, that time generally non-noble gas configuration elements, they will be always possesses higher covalent characters as compared to the noble gas configuration elements, and therefore this polarizability, again you can say polarizing power, again polarization process, this will be most important. It can be explained by the scientist, you can say Huygens in his Huygens rule. Now this idea can be taken in the Huygens rule, and applications for polarizing power and polarizability. Polarizing power of the cation can be explained. Polarizability will be concerned with the anions, and when cation, that is you can say anion can be polarized by the cations, then it is called as the polarization process. This idea can be taken here. No polarization can be takes place. Here anion polarization can be takes place means due to presence of the positive charge, anion negative charge will be attracted toward us here. Polarization can be occurs means mixing can be takes place, bonding can be takes place, and the actual bond which can be false, it is called as the covalent bonds. And whence covalent bond becomes in the ionic compounds, this will be called as the, it will reduces, melting point and boiling point becomes less. This idea will be explained by the scientist Huygens.